Good evening, everyone. So we welcome you all to the Web Dev Day. So Dev Day is an event held monthly in which we talk about the interesting things we do inside and outside of our projects. So even if you have some interesting talk, you can reach out to us. So today's talk is by Ravindra Jaju. He'll be talking on build tools then versus now. He is a leading he's a seasoned engineer with 25 plus years of experience in the industry. And now I'll hand it over to him.
My job is done. Okay, are you able to hear me in the meeting, the Zoom meeting also?
Yeah.
You able to hear me, right? All right. So the the title that you were pulled by and then the title that you see here, they are different, of course. But can any one of you relate this title to something which is famous, some famous book? A Brief History of Time, yeah. So I mean, the similarity ends there, of course. That was a factual thing. This is very fictional. I mean, it's fictional because it's my account of what I think the build tooling world has been like. I'm going to lie a lot, but if you can't figure out what the lie is, then just believe it and we can continue from there. If you figure out that I'm lying somewhere, just point out, I'll correct myself, right? Okay. So not a big deal because we are here to just talk about history, and history is typically written by winners, as we all know, right? So whatever won, we are going to hear about that. And all right. So who is in the audience? I need to figure out because what I'm going to speak is going to be dependent on who is there in the audience. So if I find people who know their stuff very well, I have to be very careful, right? So first thing, how many of you run Java in the IDE? Okay. How do you run Java? You just go click run button and do things, or what exactly does it does run when you click on the run button? I want to hear some answers because how much I will lie will depend on what I hear back from you. Is this a talk or is this an interaction? I don't know.
I usually just press the run symbol on that ID.
And when you press the run symbol on the ID, and since only one person seems to work on Java here, do you know what Java is? Okay, that was a very that was a trick question. I wasn't expecting an answer, but I was really hoping to get you all wake up. I know it's the end of the day. Java run, what happens when you run? So I'll let you not speak anymore. What happens when you click on the run button? Do you know? It compiles the code. Okay. Okay. So when you say it will make a class file, it's not entirely true. Like, that's not the complete picture. What all other things also happen? I'm also assuming that this is not a Java 101 class, right? So we are not writing a single Java file which has a main which runs, right? We're typically talking in the context of a relatively large project, right? By the way, I don't know if people on the Zoom call also are saying anything or asking for something, but just keep an eye on that. So let's expand that, right? What else has to happen? Like, how many different things have to happen? Let's try and elaborate that. So if there are two files, if your Java class that you're running refers to another Java file that you are going to use, what happens? then 2 class files will have to be created, right? If that refers to 5 other files, then it will be 7 files overall, and so on and so forth. Okay, but how does the compiler know?
Oh, hey, Jaju, can you hear me?
Yeah.
There's a class path setup that also takes place.
There is a class path setup, yes. So the notion of class path is something that we tend to not focus on when we are using the IDE because it's taken care of for us, right? So when you click on that button, it's a whole lot of things. But what are exactly those things? We will see. Um, I'll come to examples, but before we go there, one more level of question. How many of you have modified, created, or done anything with your build.gradle or build.cradle.kts file or form.xml file? You have worked with it, right? How is that related to the run command, or is that not even related? What do these files really give you? Dependencies. Interesting. What are dependencies?
Like you mentioned, if one class depends on another class.
But they're all local. And when you speak of dependencies, I'm guessing that you're talking about something which is way more than that. Okay, we'll talk about dependencies also there, but um, they give you access to a much wider world. Files that may not be present locally as well. But it's not just that, they do a lot more. What exactly are those? We'll come to that also. How many of you have actually compiled C code after college? You have? After college, okay. Like after college hours or after college? Okay. What did you work on?
Yeah, I was just following questions.
Okay. And anyone else? You're an outlier, but we'll come to you again. No one else, right? Yeah, of course, you. But then I don't want to ask you. You'll point out my lies. So please, I'll treat you afterwards. Okay. Okay. So what does it take to compile C code? C compiler. If you have more than one file, still the C compiler, of course. But what do you have to take care of?
To compile the files in the order of the dependencies that may be.
Do you have to compile the files in the order of dependencies? You're saying no, or you're just nodding your head and sometimes no. In what circumstances would you have to compile an order?
If there is a like direct dependency, so you cannot, it's not like a DLL that you can inject later in that scenario.
So do we understand the difference between compiling and linking? I can compile before something else, but I cannot link until the symbols or code that I depend on itself is compiled and available during linking, right? Okay, so I can compile in different order, but I have to link. When I'm linking, all the dependencies need to be in place. And how did you take care of that? I'm really asking you to compare the Java examples with the C examples if you have worked with C. And you will notice a few things. Java is very different and C is very different in the build tooling aspect. But C came before, right? C was the earliest. What you see with Java is, or when you see Gradle, when you see Maven, is the current state of the art in terms of build tooling in most of the world, right? While of course there are There is Go, there is Rust, there is C++ now in many places. And even their build tooling is pretty advanced. One of the key features or missing features of C and the build tooling related to C was that you had to download all the dependencies somehow by hand, make them available locally, and then compile and link and build and whatnot. Okay, and how did you get your dependencies? If you're using Linux, it would be like either download source and then install, RPM, apt-get, or PKG or whatnot, right? Whatever package manager you had. If you're using macOS, and include, by the way, Brew is also available on Linux. So if you're using macOS, you can use Brew. Okay, and you have all of them locally. Then you go ahead and compile. But when it comes to Java, you don't think. Why do you not think? Can you now tell me which specific part of Gradle? Let's focus on Gradle for the moment, or even Maven, but Gradle. How does Gradle know where to download your dependencies from? You write a dependencies block, right? And then provide what's called the coordinates. How does it know where to download from? Which is the default repository? Maven Central, right? That's the word. Okay. Okay, cool. Nice. So we have some baseline here. So we have seen the Java world, Gradle, Maven. Before that was Ant. Okay. We have understood why we need them, but not completely yet, because that's what the talk is about. So we're going to now look at some code. Okay. We'll start with Java, because that's the most familiar. I'm guessing everyone is familiar with Java, or not everyone, but at least most of you. How many of you have never used Java? Okay. Cool. So I think the example should make sense. Let me switch to something here. So can you see my? Can you see, like read the screen? No. Can you move closer, because I'm not sure whether if I do anything bigger, it will end up maybe going out of screen. Okay. Let's say that I have a very, very simple Java code base, and I have two classes here, something called hello and something called greeting. And what does greeting do? Just nothing. Given a name, it greets or returns a string with that greeting in place. Okay. How would I compile this? By hand. We're not. I mean, you see Gradle on the left hand side. Ignore that for now. We want to compile this by hand. Yes, yes. So let's try this. Java C, whole path. Greeting. Okay. Oh, compiled. Nice. What about? So I have to compile hello, or did it get compiled? I have to compile it. Someone said yeah, but yeah for what? Did it already get compiled, or do I have to compile it? I have to compile it. Okay, what do you expect will happen now? After this. So this will run and we'll have two class files. Ah. Why did the first one succeed? and the second one failed.
There was no dependency on the external class.
There was, let's go one by one.
There
Yeah.
was no dependency on the other class.
Okay. Okay. Right. So hello depends on greeting, but greeting doesn't depend on anything. Okay. So what would my class path be? Help me. So when I do this, I can tell you one thing. I can pass class path with minus CP, but now you have to tell me the path. Three again? Sure. Well, it's going to let out some secrets, but ठीक है. Dot. Complete path? Tell me. Tell me what? Like, tell me the entire path. Source main, Java. Okay. That's it? Sure? How many of you say this will fail? My nemesis. But anyway, we'll ignore him. Okay, no one says this will fail. It will fail. Why will it fail? Go ahead. Please speak loudly.
Yeah, so basically we have the file given the package name as AI.search. So what it will try to do if we give the entire path is within search, it will try to again look
For AI.Sahaj. Great. Good. So I need this to be smaller. Okay, just one moment. It will have to be only until source main Java because my package is part of my class signature AI.Sahaj. Okay, and hence it's going to be this. Right. So now if I look at tree, you see the two class files besides the Java files. Now, how do I run? Tell me the command. Anyone? The computer will not explode. Don't worry. If you give me a wrong answer, we can still fix it.
That's the main Java. The class file we need to execute.
The class file we need to execute. How will I provide it? Full path. Tell me the path.
SRC main Java AI. In the class path, you can keep it in main.
Okay. Main Java, right? And now
SRC main
the entire path again.
hello.java.
Is that how I run my Java file? I've already compiled it, right? Class. Okay. Is that how I will run? Yes, minus CP SRC main Java given. That's the for just after Java you see, right? But is this something that will run? How many of you say this will fail? Someone has to now push me because I'm feeling sleepy. Oh. Read the error. and should give you enough. Will it run now? Yes, no? Yes. No? You need to remove the dot class because it's okay. This is something that is interesting, by the way. The slash and the dot stand for the same thing. The slash is not being taken as a path. Please remember that. As soon as I give my class path, okay, so look at this. Like I am here, I am going to move outside. I can run this from anywhere now, and I do ai.search dot uh, source main Java. Sorry, right? This is exactly how when you have your dependencies and you see none of the jars in your project folder, they're elsewhere. Where are they? Somewhere. We'll come to that also, right? And you're still able to process your Spring Boot classes, your XML class, your JSON classes, whatever they may be, right? Don't be fooled by the slash here. You meant to give the path, it was not taking the path. Please remember that. The class path is a lookup path, right? Okay, so I'm going to reveal something called the make file to you next. How many of you have used make files? Okay, how many of you have not used make files? Because I like to see more hands coming up now. It's so quiet, right? Okay. So there are some people who have used and not used the Heisenberg group, is it? Because some hands did not come up.
From the chat is saying they use just files.
Which files?
Just files.
Just files. Is it? Okay. Just files. Spell that J-U-S-T. Nice. Okay. Something new to learn every day, right? Okay. So I'm going to introduce you to make file. But before that, what is make file? Make file is just a place where you record how you want to make your software, right? So, wow. My slides are over. I need to stick to the ID and the terminal now. Okay. Okay, this is a makefile that we have for this particular project. Okay. Not very hard to figure out what it will mean, but I'll walk you through the different things here, right? It can be as irritating as Python, by the way, because you see here, these are tabs. They have to be tabs. It's not a tab, the file will not run. Okay, so it will keep reminding you of the irritation of Python all the time. But if you ignore that for now, you're setting some variables, Javac and Javac flags. Okay, Javac is your Java compiler, right? Typically, we do Javac file name done, right? But Javac takes more arguments. So I can give a destination called bin. Then I can give a source path. Where are all my sources? And then I want to give my class path as bin. Okay. All is a target. And the target says I depend on the file greeting.java. If it gets modified, all will, or rather, if all has to run only if greeting.java somehow changed. And then it will invoke Javac with those flags on hello.java. And when I say run, it's going to do java minus cp bin ai.hello.sahaj.hello. And if I pass arguments, that's what it will be. Okay. Question. You never see your class files alongside your Java files in the IDE, right? When you compile, you still don't see it there. When we ran the compile command, our class files appeared just alongside the Java files. That's going to clutter up everything. It's also going to make it hard for you to keep things clean. If I had to clean up, if I had to delete them, if I by mistake end up doing a git add and commit and push, I'm going to commit my class files, right? So build tools also take care of that. So when I say destination bin minus d bin and also my class path is bin, okay, so now first I'm going to clean up. I have to be very careful because if there's space between star and dot, it's going to delete everything. Thankfully I have git, but okay. So tree, back to this, make run. Because in bin, you see, bin has the entire hierarchy replicated. My class path is only until bin. So when compilation happens, the package is taken, directories are created accordingly, and the class files will be generated, right? Now I have problem. I have to make all and then do make run. Right? If I do make run, doesn't work. Now, if I tell run, hey, you depend on all, then it works. Okay. So what is makefile? Makefile is nothing but a very, very effective, efficient, stupid Unix philosophy following kind of a tool where I can specify targets. So all is a target before the colon, run is a target before the colon, right? Everything after that is a dependency. So if run needs to succeed, then all needs to succeed. I can specify multiple dependencies, right? So what happens when I do Java C on hello? It compiles greeting automatically. It knows the dependency. The Java C as a compiler knows the dependencies and will compile them. The C compiler does not. Make was created in days when we used to write in C or assembly or any other kind of lower level or older tools, right? The whole idea of make was give me a execution graph. I am going to execute it based on how you ask me to. As simple as that. Okay. So in this particular case, I don't need Gradle. I don't need Maven. I don't need anything. Right? The problem comes when I have to introduce dependencies. What if I had to do JSON? Okay, so let's say that you had a JSON library available that you wanted to use in this code base. What would your steps be if you had no Gradle, no Maven, no Ant? Elaborate more. What do you mean by store them? What is them? Specific location, what is that location? And what do you mean by dependency? All the terms we need to elaborate.
Them is the external library, so I'll replicate them at a specific path.
So let's say I have a JSON.jar. Would you just get the JSON.jar, put them in a single place first? Okay. So download JSON.jar, put them at some place. Next step.
Step inside all, I would define a dependency to that path.
To the path. Now, all or makefile is not going to understand your Java. Okay. So you need to be more specific about what do you mean by added dependency. It has no idea of dependency in terms of code. It has dependency notion in terms of what needs to execute to make what succeed. So it's just a execution graph.
We add jar as a class path for it.
It has to be on the class path, right? And you need a jar on the class path. Now you can have an exploded jar, or which is nothing but your file system some subtree as a class path, or you can have a jar as a class, as a value in the class path. So class path is actually a long value separated by colons, where each component can be a directory or a jar. The Java runtime, when it is going to do its lookup, it looks at that class path. If the destination is a directory, it's going to go underneath and then get your classes at that path. Your dots will be converted into slashes and then looked up. Okay. If I have a jar, the dots will still be converted into slashes, but it's a virtual directory. The jar is like a virtual storage box where you can look at the internal components again in the same kind of mechanism, right? Slash separated path to something. It will pick from the jar. It's not going to explode the jar. It can read the jar directly, get only the class path, load it, and make it available. So I have to make that part of my class path. So what happens when you run things in the IDE? It sets up all of this. It will download. It will virtually create a class path. It will pass on the class path to your Java or Java C. Okay, where is that class path going to? What is it going to look like? It's amazing if you start looking at the class path that gets sent to a very small Spring Boot project also. Okay, but coming back to that. So why am I going there? I downloaded my JSON.jar, and then it turns out that the JSON.jar has classes that refer to another 100 classes that come from 10 other libraries. Now I'm in trouble. Okay. The C world was relatively much more simpler because they couldn't make it any worse. They made it any worse and they would have just given up. Like, I can't program anymore. If I have 100 dependencies which bring another 100 dependencies each, that's what, 10,000 and 100, right? I'm done. I'm not going to download, install, and keep all of them in my whatever compiler thing, etc. The corollary to that is when you first run Java on a fresh new machine, you set your any project for the first time. There is a fun way to describe it called downloading the internet. So first time when you run Java on a fresh machine, it downloads the internet. That's how we used to at least specify when we didn't have as good bandwidth as we have today. Okay. So the build tooling also gets you those benefits. But those benefits also mean that you don't think at all. Add one dependency, I'm done, right? You don't realize what is being downloaded. Your C code is, or C++ or any other thing, is much smaller. When you get into Java, for the simplest of applications that you will write, the number of things it's going to download, it's going to be huge. Okay. So let's move to looking at what a Gradle file would look like. Okay, one more thing, by the way. We haven't even looked at the test. if I were to make the tests compile and run from by using makefile, I would have already given up, because now this requires multiple jars from JUnit. Okay, that's why I didn't even think of the tests. So now I have to start writing tests. That's where my complexity starts to come. So this is your familiar. Okay, for build.gradle, let's move to. Okay, so this is my uh, build.gradle file for the same application, but now there is a way to test. Okay, where are my dependencies? Okay, sorry for the pause. I was looking at some error here. You see, the build.gradle.kts file has a section called plugins, has a section called repositories, testing, Java, and application. Okay. If I comment out application, what do you expect to see in terms of errors in this file? The last section will show errors. Everyone? Anything else that would show errors? No? Okay, let's see. So implementation is unknown. Okay, you are not able to read this. I'm sorry. I think I need to, I don't know if I can increase the font size of this site. So I'll read it out. First thing, where did it go? Implementation is a problem. It's not showing up, unfortunately, in the ID properly, but implementation is a problem. Testing is a problem. Suites is a problem as well. Okay, then can't figure out use JUnit Jupyter as well. Can't even figure out Java. This application thing is magic. Okay, okay. Let's keep it that way. Let's say I do this. The number of errors is less. It's only the application which now seems to be problematic. Succeeded. What does it tell you about Java and application and their relation? Application is built on top of Java. But surprisingly, if you're not surprised yet, I should mention that by default, Java is also not implicitly there in Gradle. While Gradle is written to run on the JVM, written in a combination of Groovy and Kotlin, now, right? It itself is a general build tool. Without application, without the Java plugin or without the Java library plugin, it will not understand Java as well. Okay. What does plugins mean then? It extends the capabilities of Gradle. Okay. The curious thing about Java is, in the context of Gradle, is conventions. If you look at the make file, I explicitly passed on things like source main, Java, etc. to the command, like whatever command I'm running. But there's nothing special about that in Java. It's only a convention, and a convention that is honored by Gradle by default. It's honored that way because Gradle picked up from what Maven built and what conventions came before that. Okay. Why source main Java? Because people figured out that I have tests as well. I don't want to put them at a separate place, but I want to keep my sources together. So someone said source main, source test. And then there were resources. So you did source resources. Sorry, source main resources, source test resources. Right? Now, if I want to use, how many of you used protobuf or thrift or like with gRPC? You have to write code in what's called the protobuf syntax, the .proto files, and they can be translated into target languages, including Java. I would store them in source main proto. I would then process them, compile them, and then the output would go to a Java, some Java location, which may not be in source main Java. To get that feature, I would write, or I would include a plugin that supports processing proto files. Right? Any kind of extension to Gradle's behavior, you can do it via plugins. If you bring in Kotlin, there's a Kotlin plugin. Until that plugin exists, your code, your IDE will not understand Kotlin. Right? So I'm going to do something here. I want to try something which is specific to Java 23. So Java 23 has this notion of importing modules. And there's a notion of modules in the newer Java releases, right? And what does it give me? Let's try. Let's see that we have this method called greet arguments, which ignore everything it does for now. Just focus on the red parts here. Okay, what are those red parts? There is list. I've not imported it. Okay, there is stream, not imported. Right. There is map, not imported. String, not imported. Right. Now, what I would do in pre-Java 23 preview is import, right? So this is what you would end up doing. Like do this, import. Asks me, choose one, do this, import, right? But I don't want to do this because Java 23 gives me something which is nicer, which is for my base module, all of these will be available to me by default. Okay, I'm not here talking about features of Java 23, but I'm here to focus or emphasize on one thing which is important for us, which is how does the IDE just behave as if it is Java? read on the absolutely precise line. That's worth thinking. This is where, again, the build tools provide the IDEs with enough information and precise information to help them deal with your code very well. Okay, what that means is I can go to build.gradle.kts. What I can do is I can modify the behavior of certain things in the environment in which the IDE operates in conjunction with the Gradle tool. Okay. I have not included anything. It's still application, but notice this. We have not been using this. There is a block called tasks. It's always been there. Again, there are tasks which are by default available and behave in a very specific predetermined manner. And if you want to modify them, just catch hold of them and modify them. So compile and execute are two tasks that Gradle application provides, or even Java provides. Okay. What you're telling compile and Java exec is, I want the -- enable preview option to be available when you start up the JVM. And then when the IDE will talk to the JVM, the IDE will be just fine. I sync my tool, right? And let's go back to hello, and the error goes away. While there is a lot of IDE magic, I want to emphasize primarily on the fact that this is also supported very well by Gradle, which is your build tool. And the build tool has enough knobs, but then most of these things have been hidden from you because the defaults have always worked. Right? With me until now? So when I have this import module java.base, I don't have to do like very explicit imports on map and string and so on and so forth. It's like these are common things in Java. They made it available in java.base export by default. If I import a module, so you can also create libraries and then export only modules and very specific things, even though they are across packages. You can organize in different packages and export through modules. Okay, but this is the build tool that is making it available to the IDE as well. The IDEs also know how to integrate very well with the build tools. All right, all good until here. Okay. And at this point, if I run this, I'm running this with few arguments: cricket, tennis, bat, banana, and ball. And this greet arguments does nothing but group them by their first letter. And then for each of those letters, it just does a hello on all of them in a sorted order, right? So for B, it's blah, blah, blah. For C, it's cricket. For T, it's blah, blah, blah. Hey, it showed hello cricket and under T. I don't know, there's a bug, but we'll ignore that. Okay. Are we done or there's more? We didn't go to the history. So let's go back in time. Okay. Because this was just to set some context of what you already do use on a daily basis. But it wasn't all this kind of thing before. But there's also a flip side to it. When you have to do something which is like out of the normal, you really have to know your Gradle very well. Okay. But it started initial days C or assembly or whatever it was, run the C compiler, then get output, run your code, right? So I'm bad with names and also did not put it in my slides. So I'm not going to tell you who the inventor of Make was. A Google search will give. I'm sorry about that. Great guy, but I should apologize. But the story goes this way that there was another great guy, again, all at Bell Labs. And Bell Labs was an amazing place. Is probably I'll stop there. And Unix grew there. A lot of tools grew there. So there was this person who invented or was, kind of, I don't know if invented, but of course he was doing the compilers stuff. Yak. How many of you used Yak? It's a tool for creating compilers, right? So Lex and Yak used to go together, and you would use Lex for creating Lexes and then Yak for building DSLs. I mean, we call them DSLs now because it's very fancy, but it was like you wanted to build your own language, use Lex and Yak, and then you're done. So this guy came like, or rather, both of these met at some place. I don't know who went to whose office, and the person who had not yet created Make was speaking to this Yak guy, and the Yak guy was probably Yak shaving, is frustrated, and he said, "I fixed everything in my code, and I have spent a lot of time, probably overnight until the next day, figuring out why it was still not working, and then finally it turned out that he had been linking his .o files without recompiling the C file that he had changed." To repeat, he forgot to recompile the C file while he modified it, but he was trying to debug the executable, and he was losing his mind on, okay, I just lost it, right? No, I did not realize I had not compiled it. Why? Because people would compile by hand. CC in those days, right? No GCC then. CC file name, wait, like, get your output, link all of them. So compiling is CC minus O, linking is the default, which is just CC. It does the compilation and linking, right? But you can even do them individually. The problem was that you didn't want, it was so time consuming that you did not want to recompile each and every file again and again. See, in today's world, you would simply do cc star.c and done, right? You would not think. Speed matters. It wasn't as speedy in those days. So he avoided recompiling because there was a lot of useless compilation to do, and I've only changed one C file. But he ended up spending so much time debugging. So this gave the idea who wrote Make, this gave the person who wrote Make an idea, saying that if I could create some sort of a tool that could understand what needs compiling and then compile that, it would be so helpful. And what is the most obvious thing to do? I have a .o file, right? So let's go here. I have greeting.c, right? So I do this. The next time I run make greeting.o, what does it say? Up to date, did not recompile. How does it know? Simple, right? The timestamp of greeting.o is later than the timestamp of greeting.c. So my greeting.o was created after greeting.c was modified. If I could do that for all files, even if there are 100 files and only 2 files have their .c which are newer than their .o, I will compile only those 2 files. That was the only idea. He converted that into an entire Make tool. Okay. So what does this Make file look like? Well, this is, I mean, it's not written in the easiest of manners, but it's kind of efficient. So I say percentage O dot C, percentage O dot O and C, sorry. It says my O depends on C for whatever value of percentage. And to go from O to C, go from C to O, I should do CC, C flags minus C, and then the input. Minus C stands for compile. If I don't do minus C, it is compile and link. Okay. I'm guessing that the compile link phases are understood by people. I mean, it's not going to come in the way, but if you need anything, if it's confusing, I can explain. So if I can write my DSL or my directives in such a way, I'm done. Why? Because if I do make main, main can check that it depends on main.o and greeting.o. It first checks for main.o and says, okay, there is a rule to create main.o from main.c and I have it. I will compile it. Then there is a rule that creates greeting.o and I have greeting.c, it will compile it. When both of them have run successfully, I link. So I take the CC command, the C flags command, minus O is, so $@ stands for the value before the colon. So it's automatically the name of my output file, which is going to be my executable. And then so there are shortcuts here. Ignore them because you can always look them up. But the whole idea was I can create a dependency graph and do things this way. Okay. It solved a very key problem in those days. It solved it very simply, very beautifully. But it wasn't as sophisticated as Java. I don't know whether we need the sophistication or not. That's a different debate altogether, because now to write a very simple thing, you will end up downloading 10,000 and 100 jar files from the internet. But if you ignore that, it's very powerful, right? The dependencies, all of the ID integration, whatnot. This works. So now if I do, let's start again. If I do make, it did those in 3 steps. Main.c, greeting.c, and then main. So if I do ls now, main is here. Okay. Straightforward, right? This is kind of the beginning of how powerful build tools started to come. People still had shell scripts, by the way, right? But Makefile makes no assumptions. I can still use my shell scripts and call them from Makefile. I can call Java from Makefile, right? I can pretty much do anything from Make. Right? Okay. So now we have seen Makefile. We started with today. We went back in history. And then in between, there were too many other tools. I don't know if you have heard of Ant. Okay. I'm going to just call you out, guys. Like, we were not even born when Make was created or Ant was created, or probably even Maven was created. So it's okay. You got saved from the ants biting you, but it was a whole lot of XML. Okay.
Hey, Jaju, I managed to use Ant and Ant IV both.
Nice. I mean, I
Not
don't.
nice.
Yeah, of course. My sympathies. Sorry, that's what I meant. But yeah, and but you want to share? I don't know. Is there more you want to add there?
Uh, it's a lot of manual effort, but there's a lot that goes into learning about how your tooling and your build process takes place. And I had started off with Ant, so there was no dependency manager in Ant specifically, and that's when downloading jars was pretty much manual. And then a year later, not a year, a few months later in my career, I learned about Ant Ivy, and I got way too excited about not managing to download the dependencies. And from there onwards, like that was purely XML. From there onwards, then I got introduced to Maven and then to Gradle and so on and so forth.
Yes, absolutely. The evolution, right? So people were not happy with Make for whatever reason, because XML was the cool thing in those days, and Java people did not want to do anything with C. I guess so. Again, as I said, I'll be lying, and if you can't catch my lie, then that's the truth. So when how many of you have heard of XML SOAP, RPC, XML SOAP, RPC? I see Puneet hiding and smiling and then hiding again. Okay. It was, they still thought it was important in like 4 years ago, 5 years ago, 4 years ago. Okay. Yeah, I mean, see, this is how outdated colleges can be in their curriculum, right? They they will absolutely miss the bus and then some more. So XML was thought of, okay, I think it's important to not demonize it as much. Okay, so let's actually start from the reason why you needed Ant and XML. The whole idea of Java was platform independence. The whole idea of Make was Unix and shell scripts. So while Make could execute anything, the problem was that there was a lot of fragmentation in the early days. There were too many Unix flavors, too many shells. Each shell had a different behavior, not necessarily having even the same commands and same tools, or tools having the same arguments. Okay, so people had to get into a lot of if-else kind of tooling to make their build work fine on all kinds of platforms. Okay, so when Java came, the most obvious thing for people was, hey, for Java, this Java promise of being platform independent, we need to take it further and make it available for all kinds of things on Java. I can't run Java with Makefile. Okay, so what is the syntax I could use? Now you invent a new syntax, or you pick something that is already in place. XML was a very in thing in those days. The reason is going to be hard for you to imagine, but there was no JSON then, right? JSON came as a response to, hey, I'm done with XML. But XML was, there was SGML, there was HTML, and hence XML just made sense. Okay, why? Because it was extremely structured, and people had this notion of machine understandable code. So executable code was there, but what if I could have text machine understandable code? XML made sense. So people started bringing that together and saying, I can take this XML. If Java is available, jars will run in the same way. My Ant, which is nothing but package jar in some way with some way to execute it, some shell scripts, will just work with this XML. So that was the first step. Okay, it was like, let's do Make, but in a platform independent way. But then with Java, the next thing was, I need to get jars. Java was not Unix, right? With Unix, you had a lot of things pre-packaged, or you got the C code, you compile, you could do make install, etc. There was some standardization there. I've not talked about the auto configure, auto make, those kinds of things in the C world. They still exist, but there is the XML thing that made things pretty independent. Then came Ivy, which was sort of an extension that you could use with Ant. So you have to configure Ant and Ivy to get platform dependency management and your code to compile and run and whatnot you had to do, including your war building, EAR building, jar building, whatever it was. Like in those days, it was more than jar. People had web applications, so there used to be wars and EARs. Have you heard of wars and EARs? Enterprise Archive and Web Archive. They're still zip files. Jar is also a zip file. Okay, it's just the convention in which things are packaged inside and some metadata exists within those files, right? And because the application servers then knew how to use them. Then came Maven, they said, I'm going to merge all of these together, make it slightly more palatable, the XML. So it is still XML, but it's more focused towards making life easier, not having to do too much of it. So conventions, they started bringing in this idea of conventions. Okay. People again got fed up with XML and they were getting fed up, but they got fed up finally and someone said, I'm going to use Groovy, which is the nice language, dynamic on Java, so I can do a lot of nice DSL stuff. And then out came Groovy, so Gradle, built on Groovy. And then again, problems solved, more problems, more solutions. Kotlin is much better. So even the Gradle people have started moving to Kotlin, right? So that's the journey of one line, right? In the C world, people still had those problems. Okay, so I'm going to take one example of another tool that came as a evolution in the make space called CMake. While the name is CMake and it was targeted towards C++, it is also more capable, right? But the primary use case is for C++ applications. Okay, so now as you can imagine, there was still this gap in the C world on how you would get platform specific builds to happen in a shell independent way, in a command independent way, something that would work across the board. So in computer science, there is a saying, right? Almost all problems can be solved by one level of indirection, right? Or one level of abstraction, right? A pointer, convert that into pointer to pointer, right? Or convert that into a pointer to pointer to pointer. Or introduce an interface. Or introduce a super interface, right? And you will solve all problems of the world. That's the idea. So CMake or Ant or whatever, these are all just abstractions going one level up. Let me give you a quick view first of what a CMake configuration file looks like. Now this is very different from your make file, but it's more declarative, right? So what does it say? If line number 4 and 5, they simply say use the C++ 17 standard. This or the next 3 lines, 7, 8, 9, these are the interesting ones. I want to use the threads libraries. I want to use protobuf and gRPC. I can mention this. And how does it work? CMake has internal tooling that can look up some paths that you have set, your CMake config path or other standard paths on your OS. It can look for CMake configuration files for threads, protobuf, gRPC. The name again is found by convention. There'll be some prefix, some suffix .cmake to the name that you give. It will look for those files. Look inside those files. There will be a library of further configuration routines inside them, and it will configure your variables. What are those variables? My include paths, my library link, the libraries that I need to link to, etc. So first is find these packages. If I found those packages, you can, just to inform yourself, you can say I found so you see this string, right? Protobuf, then underscore version. That's just the convention. That value is stored. So gRPC, the same string, underscore version. By convention, you will see those values. It will say I found those versions. You can see what those are. You can also, if you see the first one, CMake minimum required, you can even give the minimum required or maximum to these versions to make sure that your build happens in a very predictable manner. Then once I have these protobuf CMake files, a protobuf generate library function becomes available. Then I can compile my proto files into .h and .cc. Similarly for gRPC, gRPC.h grpc.cc files, which are my C++ and header files. And then finally, of course, also libraries. So I add my libraries, protobuf and grpc++ to my proto library that I've created. And all of them finally get linked to my final outcome. Okay, this is CMake. What happens with CMake is, do you see, this is the output of running CMake. So I'm going to run it again. So rm-rf build. I'm saying create all your output inside the build folder. That's what -B build means. And dot means all your configuration starting point is dot, the current directory. Okay. So I have deleted the build folder. Okay, that's tmux, so it's not going to. But anyway, you see protobuf 2930, grpc 1.70.1, right? ASIO, which I asked it to look for. And then it says finally build files have been written to build. What do you see inside build? A lot of files. Anything of note here? Make file. One level of abstraction, as I said, right? CMake generates make file. What does the make file look like? 369 lines, okay. Would you be able to write this file by hand? No. So that's what CMake does, okay. And then I can simply run this in the following way. All good, right? The proto files are in proto, which have, like, for very simple demo, just a request, a response, and a service method. That's an RPC. So I can call key check on the server side, on the client side. The server will respond with the right values. How do I use it? I can use it by writing that code here. It generated all the classes within the right namespace, all of that, right? Where are these? They're in build generated. You remember that's the directive we gave in CMake, right? And finally, okay, it's running, so I should stop and start. The command compiled, it runs, it listens on port 18080 for HTTP and 18081 for gRPC. And I can do okay, I should show you the code first, right? Because so the code is an HTTP server which has two endpoints. If it matches hello, it just says hello world. Otherwise, it just responds with the string. So if I do FOO, I get input FOO. But if I say hello, I see this, right? I am running it just to tell you that this is real code, right? Not made up code. Because I've lied so much that I have to show you some truth. So why are we here? The whole story is CMake is still important. CMake is still used in the current world. If you're not doing Java, if you're doing Rust, Rust has cargo, right? Go has inbuilt build tooling, all of that inside. But C and C++ are still not going anywhere, especially they're more and more important now, given the amount of GPU programming that we are doing these days. Okay, and all of them are mostly still in C and C++. Okay, so it's worth knowing Make. It's worth knowing CMake also. It's worth knowing Gradle definitely. If you're in the Java world, stick to Gradle. But at some place, you might still find Make useful today. Okay, why? Because Make is very extensible. If I have to, okay, so now let's take one final example. I want to run my tests or run my application as soon as, and I'm talking about the Java application here, as soon as, whenever the file changes, I want something to run. How would you do it? In Gradle. That's the ask.
You can start a daemon that looks at the file changes.
You can start a daemon that looks at the file changes. How do you start that daemon in Gradle? Okay, so help me. We will try it. So what do I do now? Pass in a flag. What flag? You can look up. This is not an exam, so go ahead. You can do Google if you want to help me. Hyphen T. And that's it. What are my input files?
Current Gradle can help, the current project.
So which file? I want to watch, let's say, one file. When it changes, the program should run. Let's keep it simple. So what is T looking for? What is T looking at? Minus T.
The files inside my project.
But then I have too many files. So what? Which file? Only inside source. But it's changing for any of that. What if my resources file changes, which I depend on? So simple things you can always do, like minus T, but then you have no control. I want precise control. What will I do? So if you're a $1 billion funded company, you'll say, let's write a new plugin. We'll create a new team for it, right? What will we do, right? If let's say that I have a very specific need. Forget a file in this particular source main, blah, 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 right? It could be like, do something or run the tests whenever maybe my git pull did something, it modified a resources file or something, maybe, the database change or something else happened. It's hard to think of how you would do it in Gradle. So you would do a Google search, then maybe you'll figure out something, then someone may have written a plugin, you'll get that plugin, then you will struggle with the syntax, right? Look for examples, then try it out. If it doesn't work, you ask ChatGPT now, but still ChatGPT doesn't know of that new tool. So the Unix philosophy is build one tool that works well only for that task and let people figure out how to combine them. Okay, so only thing I need to do is find a command that triggers anything when something changes. It does not need to be anything related to Java or C or anything in the world, right? Isn't it? So if I were a makefile person, what I would think is, okay, I know of a command called arilo. Okay. And I ask it to watch only this one specific file called hello.java, but I can make it watch anything. Okay. And then whenever that file changes, just run this. Okay. But then why here? Because I don't need to remember all of this. I'll copy this. I will do a make file, write a target called watch, place it here, and do make watch. And here what I need to do is, oops, see, triggered that immediately. You don't have to think much. If you know your tools, if you can just use something as simple as this, use makefile as a place to just record your complex commands. And then you never have to remember doing it, check it into your code base, and make people use it. Make can call Gradle. Make can call any shell command. It can combine anything in any which way and just do what you want. For simple things, use simple tools. Don't end up always getting into complex solutions for things that have very simple ways to solve them. Right? So yeah, yeah. So in summary, this was kind of my story of the history. The real story might be different, but it started with shell scripts. Then went to make with a very nice, interesting incident behind it. Just one incident, but that inspired someone to create Makefile, which has been around still today. Then CMake and blah, 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 all of that. There are parallels in, so if you look at Go and Cargo, for example, Go has built-in dependency management, right? You just do Go dependency add, etc. It will download from GitHub. So Go took a completely different approach, saying everything is open source. It's there on GitHub. I'll by default get from GitHub, compile, and then make it available. Cargo also has a a very similar flavor that the thing is maintained by the Rust people themselves, right? Only for Java, because it was somewhere in that evolutionary phase, someone else ended up writing these tools, but now they are becoming standard. Okay, and you have done JavaScript. Your package.json, the script section is essentially that. Right? It gives you JavaScript, but it also gives you those strings which are nothing but simple calls to your shell script or your shell through your shell. Okay. All right. That's it from me for today. And please join the meetup group if you have not already for more Dev Day talks. Yeah. Thank you.